Here's a question from the text where we're asked to find the antiderivatives of this function, and so we were looking for the antiderivative of the square root of x plus 1 over 2 times the square root of x dx. And I have to be as honest as I can be when I tell you that I can't see this very well. I can't see what the next step is, but I know that if we follow the algorithm that we've been using, that is to rewrite, to integrate, and then to simplify, that I think I might be able to see this a little bit better. So rewrite. So I'm going to rewrite this thing. If you don't mind, I'm going to rewrite it in a way that I don't usually rewrite it, but I think it makes sense. Let's try it. So the antiderivative of this is square root of x, so that is the same as x to the 1/2, isn't it? Plus, and I'm just going to, I better put the x here, huh? The antiderivative of 1/2. What I did here, here's 1/2 is this 1 over this 2 is this constant multiplier. I just pull it out, right? And this square root of x is in the denominator, so it's x to the negative 1/2 power, right? Dx, right? So I have this thing broken out into some pieces here, and now I'm going to see if I can't start to integrate, right? It's right. I'm sorry, it's not. It's rewrite, integrate, simplify. So I'm going to try to integrate a little bit. Remember, when you integrate, you get rid of the integral sign. So I'm going to start to integrate. And when I asked Willow how to do this, Willow said that the best way to do this would be to take, this would turn out to be x to the 3/2 over 3/2, right? That's me integrating this piece right here. And then this piece would be this plus, and this 1/2 right here is this 1/2 right here. And when I integrate this, right, I'm going to add 1 back to this, so this is going to be x to the 1/2 over 1/2, right? I was reminded many times today that I was continuing to forget to put c in there. So there's our c value, right? Okay, so I integrated here. Now I need to simplify. Remember that this is a complex fraction, so this comes up this way. So this 3/2 comes up as 2/3. X to the 3/2. So this is this 2 is this 2. This 3 is this 3, right? This came up that way, right? This comes up as 2, doesn't it? So 2 times 1/2 is just 1, isn't it? We get x to the 1/2 plus c. Okay, so I think this is simplified. Actually, it's not simplified. You can pull this out here. We can pull out x to the 1/2 times 2/3 x plus 1. Can't we? Right? Plus c here. I think works good, doesn't it? All right, so I'm going to get rid of this for now, the simplification, because what I want to do now, I want to prove that this is correct. And the way I'm going to do this, I'm going to take the derivative, and if the derivative comes out to be this, when I test this, if the derivative of the function of this function right here turns out to be this, then we're money in the bank, I think. So take the derivative of this. So if you don't mind, I'm going to take just a second. I'm going to call that thing f of x, and I'm going to say it's equal to 2/3 x to the 3/2 plus x to the 1/2 plus c. I'm going to use, right? I'm going to take f prime at x, and I'm going to take ddx of this, then ddx of this plus ddx of that. Well, ddx of this is 3 times this is 6 over 6, isn't it? 6 over 6. 6 over 6. Wow, 6 over 6. X to the 1/2 plus 1/2 x to the negative 1/2 plus 0, because ddx of a constant is 0, so plus 0. And simplify that out a little bit. 6 over 6 is 1, so right, square root of x plus, look, this 1/2 here is 1 over 2. This is negative, isn't it? So square root x f prime at x is this mess. Does that match? Does that match? Does that match? Yes, it does. Is this the same as that? And it is. So check mark. Good for us. So, okay. Another question solved. Good work. Want to see a picture?